soalnya ini tadi udah dipakai buat ngetes, berarti buat yang nanya.
Berarti ini buat yang berbicara. Oke. Masih. Lagi pakai keyword.
Ditunggu sebentar ya, kita tunggu rame dulu ya, biar bisa bareng-bareng semuanya nanti. Mungkin juga jam 1 ini. buka ini dulu ya, Sony. Buka, astagfirullahaladzim, bukannya belum. Download apps-nya dulu. Ini nggak terlalu gede kok, kecil. Apps-nya juga. Untuk source code-nya bisa diambil di sini. Ntar saya bikin shortlink dulu deh. SID. Bisa dibuka di sini, nanti sesuaikan sama OS aja. Ada yang pakai Mac, ada yang pakai Linux. Nah, depan aja. Lebih enak. Bipop. Oke. While we're waiting for the other participants to join, we can download this application first, the IDE. And the source code that we will be using is on my GitHub. This is the short link for the source code. Is there a non-bahasa speaker? Bahasa Indonesia is okay? Bahasa Indonesia? Sambil takutnya ada yang dari luar juga gitu. Saya khawatirnya gitu. Fleksibel aja saya mah. Kalau misalkan ada yang dari luar ya bisa pakai English, ada yang pakai yang kalau semuanya lokal ya kita lokal aja ya. Ada berapa? 1, 2, 3, 4. Soalnya ini ada kitnya terbatas. Ini, by the way, ini handphone ya. Saya nggak bawa pulang ya. Soalnya buat workshop yang lain lagi. Jangan. Jangan. Yang saya bagi-bagi nanti stiker ada ya. Iya, ESP, basically ESP. Oh, chip. Oh iya, chip yellow display. Itu lagi hot. Lagi banyak yang pakai. Itu biasanya buat ini HMI, Human Machine Interface biasanya. Cepat itunya untuk apa? Untuk developnya. Satu-satu pakai kabel USB data ya. Oh ya. Oke, ini ada 2 jenis ya, jadi terbatas, jadi cuma 10-10. Kalau untuk XIAO-nya sih sebenarnya ada 20, cuman untuk yang bentukan kitnya gini ada 10, jadi nanti sisanya 10 akan saya bagi 2 ya. Kenapa yang satu lagi ini saya konekin ke sini dan kenapa yang ini pakai yang ini ya. Ya, Type C. Udah? USB Type C aja seperti pada umumnya. Oke. Oh, join aja. Join aja. Oh, pada joinan nih. Oke, sebenarnya saya ada beberapa mandatory presentation ya, karena bisa dilihat dari sini sih ada dua brand yang sponsorin saya buat kesini, jadi nanti saya minta waktunya sekitar 5 menit untuk presenting sponsor saya. Sebelum kita ke materi. Mas yang dokumentasi siapa? Saya mohon bantu foto ya Mas, pas saya presenting sponsor aja. Mandatori ya. Oke, yang baru datang tadi siapa? Masnya baru datang? Oke, sebelumnya perkenalan dulu sedikit. Ayo Mbak, monggo Mbak. Mbak peserta. Ya, sini aja Mbak. Biar enak Mbak saya manage. Soalnya nanti saya akan banyak mandu secara langsung. Jadi biar mobilnya saya enak. Ini nanti diambil ya buat Mbak satu-satu. Dipinjemin bukan buat Mbak. Saya harus perjelas dulu nih. Oke, selamat pagi, selamat pagi kan. Ini belum sarapan ini saya. Selamat siang ya, selamat siang. Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, saya Hendra dan ini merupakan Pycon yang ketiga saya. Saya udah ada dari Pycon pertama di Surabaya di 2017, yang kedua 2018, setelah itu vakum, baru kali ini comeback. Dan 2017 dan 2018 materi yang saya bawakan sebenarnya MicroPython juga. Tapi yang sekarang yang saya bawakan MicroPython yang lebih update-nya. Dan waktu itu juga cuman talk doang, nggak hands-on workshop. Kalau yang sekarang ini, saya pengen teman-teman juga coba ngoding MicroPython secara langsung, hands-on. Dan sebenarnya perkenalan dulu, saya Hendra, saya dari Universitas Raharja. Kita bakal sedikit adjustment bahasa ya. Oke, where are you from? India. Okay. Are you participating as well with this workshop? Yeah. Okay, have a seat. Okay, akan ada sedikit adjustment bahasa ya. My name is Hendra. I'm from Tangerang. I'm from Universitas Raharja, and also I am one of Seed Studio's ranger. Seed Studio is a maker company or a company, electronic company from Shenzhen, China. Okay, okay, 404. That's good. Kayaknya belum pernah seperti ini. Pakai S. Oh, sorry. Wiki. Okay. So Seed Studio is a company that made the board that you are using right now, a maker company, and also they mostly focus on AI hardware at the moment. And I am also happen to be one of the ranger from Seed Studio. Ranger is a representative for Seed Studio. There are a bunch of ranger separated in all the world. There are one in US, one in Colombia, one from India, one from Italy, and one from Tangerang. Yeah, so. Okay. A little bit about Seed Studio. Seed Studio is a company that made a lot of makers hardware at the moment. They also already cooperated with a lot of companies as well, like Arduinos, Raspberry Pi, and also they made some custom module for Raspberry Pi, if you guys know Raspberry Pi. Also, they recently have a cooperation with this guy, NVIDIA, one of the top leading hardware in AI at the moment. Yeah, if you learn about AI, data analysis, or any kind of sort of things, you must know about NVIDIA's. Okay, one of the industrial products from Seed Studio is the SenseCap line of products. The SenseCap is actually an industrial grade sensor that you can put in anywhere, like in agriculture, in industrial, or in environment. So this is basically inside of this thing is a sensor, like various kind of sensor, like temperature, humidity, AI sensor. But this one device can run up into 2 years without charging. And it uses a long-range communication called LoRa. LoRa, if you have ever heard about LoRa. And the SenseCap itself is one ecosystem. So it could be a solution if you want to do some kind of monitoring in a huge area of farm or in a huge area of a factory, some kind of asset tracking. But you don't want to use Wi-Fi. You don't want to use 4G. You want to use your own local radio network and use your own, because LoRa is low power. And it doesn't take a lot of power, and you can manage your own network. It's a different kind of radio. Oh ya, boleh. So this is the whole ecosystem of the SenseCap. I'm going to be quick because I don't have much time. This is the ecosystem of the SenseCap. So if you want to deploy things, doing some kind of monitoring with the SenseCap, this is the diagram. Yeah. Maybe if you know LoRa, you maybe heard about Helium Things Network, LoRa. Helium is actually a bit unique. It's actually a LoRa framework, but Helium also generates its own coin token. So every time you send a data, IoT data, you also generate a coin. It has its own coin. It's called HNT. You may Google it after this. So every time I'm doing some IoT stuff, I also get a coin. But the coin value itself is quite low at the moment. Okay, this is the products. This is the gateway for the LoRa SenseCap. And this is the tracker. This could track any kind of things that you want to track, like a package, like a car. But you need to make your own LoRa coverage in the area. So using multiple, this thing, yeah, you can this thing can cover up to 5 kilometers. And you can change the antenna, you can get another 10 kilometers with your own coverage. It's a different kind of radio. And using this, you can do tracking. So this is the node, this is the gateway. Edge computing. Sicily is also one of the Raspberry Pi approved design. So this is basically a Raspberry Pi redesigned, Raspberry Pi for industrial. It has some kind of standard and specification that already passed the certification. This is the R1000. And also NVIDIA. There are a bunch of repackaged NVIDIA's module, especially the Jetson line of product. There are Jetson Nano, Jetson Orin, and Jetson AGX. If you've never heard of those kind of modules, it is actually a specific kind of module that runs AI directly. It has like 10 tops, 20 tops, or 2 tops. So this is the line of products, and as you can see, there's a generative AI in there. So this small little computer can run its own LLM. So you can run your own local ChatGPTs on the computer itself. There are already tutorials. And also there are the industrial version as well. This is the user case. This one is for the parking lot management and all that. Cecilia also provide some kind of ODM if you want if you have some kind of offer, some kind of request that needs to be white label. So you actually like an OEM. So you actually use Cecilia product, but you can rebrand it to your own using the OEM service. Okay, that's it. I don't want to cover it as much because I don't have much time for this. Okay, let's focus on the material for today. So, I just found out some kind of challenge for today's workshop, but I will explain it later while we're deep dive into the XIAO itself. So, if you have never heard about microcontroller, this is what we are going to use today, what we are going to focus today. Microcontroller is a small integrated circuit, or IC, or chip. Sometimes we call it chip, sometimes we call it IC. Designed to perform specific tasks in an embedded system. It contains processor, CPU, RAM, ROM, and I/O and peripheral on a single chip. So this single chip, the ESP32 chip, it actually already contains its own RAM, its own memories, its own processor. That's a microcontroller. So it's only one package. But the computing power is low. It doesn't run Android, it doesn't run Windows, because it doesn't have to. Because it can only run one specific task. That's a microcontroller. Oh yeah, makasih. Yeah, this is the part of the microcontroller. There are CPU, maybe you already know what CPU is. Memories, 2 kinds of memories, RAM and ROM. I/O modules. It also has its own timers. And peripherals. The peripherals is used to connect various kind of things, various kind of sensors, various kind of peripherals or device. The most standard interfaces are these 3: UR, I2C, and SPI. So there are a temperature sensor that uses SPI. There are also a humidity sensor that uses UR. That depends on the application. I don't bring any sensor at the moment because I don't bring that much, but there are samples that you can use sensors to monitor various kind of conditions using this kind of interface. And also it has its own ADC, or analog to digital conversion. Analog data to digital, and also digital to analog. Common uses of microcontroller is on regular daily device that you are using, like TV remotes, washing machine, microwaves, air conditioner, and automotive, like engine control units. You guys know engine control units? ECU. Yeah, ECU in a motorcycle. Airbag system. Actually, many Indonesian people are making their own custom ECU using Arduinos. Yeah, there are many people are selling their own ECU using Arduinos. Also, home automation, smart thermostat, security system, IoT device, like the one that we are trying to build at the moment. sensors, smartphone device, wearable gadgets. 3 popular microcontrollers in academic or maybe in the maker communities. These are the 3 that are most popular. But in industrial, there are a whole other different things. There are STM32, NXPs, ARM, and other things. But if you are just trying to know or trying to learn about microcontrollers, these 3 are the most popular chips on the market today. The first one is Arduinos, or most people call it Arduino, but it is actually the APAC 3280. Its architecture is AVR, it's only 8 bits. The flash memory is so big, it's only 32 kilobytes. And the RAM is only 2 kilobytes. So imagine, compare it with your smartphone. It's a huge difference. Yeah, 2 kilobytes and what, 8 gigs of RAM. It's a huge difference. But at the moment, this one is pretty left behind because most people already move on to ESP32 because ESP32 have Wi-Fi and Bluetooth capabilities, while the Mega doesn't have those kind of capabilities. So embedded inside the ESP32, you already have your own Wi-Fi connectivities and also BLE connectivities. And also it has better CPU, better RAM, and better memories. Bigger memories, bigger CPUs, and bigger RAM as well. And the new guy or the new kids on the block is the RP2040 or the Raspberry Pi Pico. It's actually from the Raspberry Pi Foundation. They made this small microcontroller also to the micro community because it's back from the Raspberry Pi. Raspberry Pi has a huge communities, and people love using this, like to using this. And there are already so many projects made. And also the RP2040 or the Raspberry Pi Pico out of the box already supported with MicroPython officially. So XIAO, why you are using XIAO? Because I'm using SIS video. Oh no, because XIAO is basically the ESP32S3. ESP32S3 is the recent iteration or the most powerful version of ESP32 at the moment. Actually, there are better version as well, but it's one of the most affordable as well, and the smallest and the biggest RAM. But why in XIAO? Well, in XIAO because if you guys know Mandarin, XIAO means little or small. Hence the name. The form factor of the XIAO board is only as big as your thumb, so it's so small. So you can make your own custom project using this small board. Imagine if you are using, oh, I want to build a custom project and I want to resell it. I want to make it like my own products. Imagine you have to learn how to solder these pins. This is have some quiet learning curve in it. Quite difficult. If you haven't even soldered it yet, this is quite difficult. So with the XIAO, it already has its own pinouts in here, some small holes. So you can make your own products with it. Support MicroPython and MicroPython, and also Arduino and other programming language. Okay, why MicroPython? MicroPython is like Python implementation, ideal for microcontroller frameworks, fast prototyping with easy to read syntax. So about MicroPython, MicroPython is a Python implementation that runs inside the microcontroller, not in your computer, but the Python, it runs inside this small chip. So imagine, so when we code MicroPython, we actually open up the MicroPython inside the chip, inside the ESP32, and we debug it, and we configure it based on what we want. Okay, this will be the summary of our workshop. We want to try to use the XIAO, and we want to try to set up and learn the MicroPython basic, and build a simple IoT application, and also implement a camera-based project using MicroPython. Also, I have this for the guys who are using have help. This is actually a tiny ML, tiny machine learning modules. So this small device has its own machine learning engine, as small as a microcontroller. I will explain about this later. Okay. So while we continue, for the one who just come in, I want you guys to download the Sony apps, Sony application. Oh, Mbak Manya nggak bawa laptop? Bawa? Buka aja Mbak. Apa? Does anyone already have their own ESP? Who hasn't? Okay. So to run all the shell that I am already give to you guys already have MicroPython inside. Actually, if you want to run MicroPython, you need to install the MicroPython itself to the shell or to the ESP32. There are a few steps. So I install the shell. I install the MicroPython directly to the shell before I'm giving to you guys to cut the time. So if you want to install it, it's actually you need to do two small steps. So it doesn't have to be the shell. As long as it runs ESP32, you can do this also. Do this as well. So I already made a documentation or wiki on how to run MicroPython. This is written by me. So first thing first, you need to download the firmware. You need to download the OS itself. It's small. It's like 2 megabytes or 1 megabytes. Download, and then you need to format. What I mean format is delete the flash memories of the ESP32 using these tools called ESP tool. You can install the ESP tool using pip, still in Python. If you know pip, Python install package. So this is what you do. You need to ESP2.py, and you need to set the COM port and then the erase flash, and then you need to do these commands. But you don't have to do this right now because I already installed the MicroPython on all of the devices. So, but what if you want to try to use it with Arduino? Still, you can do it also. You just plug it into the Arduino IDE and then upload the code like you used to be. And then the MicroPython firmware will be erased. And then it will run Arduino. But as long as you don't erase the flash, this still will run the MicroPython firmware. Okay? Sony? Everyone already installed Sony? Okay, already. Now I want you to plug the shell to the computer. Everyone bring their own USB cable data already. And we need to find who's using Mac. Anyone using Mac? Because Mac is a bit different to find the COM port. Okay, Mac's a bit different, but I think it's still capable to do. Mana sih lubangnya? Ah, ini dia. Okay, plug the shell until you hear that sound, the most common sound. And then we need to specify. We need to specify the address, the COM address of the microcontroller. Click run in here, run. and then click the configure interpreter. Let me know if I'm going to pass. Okay. Click click run on the Sony app. Click configure interpreter. Choose MicroPython ESP32. So if you want to use like RP2040, there are already the option in here. There is also an option for BBC microbit. If you know BBC microbit is actually on the workshop class 1. I think Anthony is sharing about the BBC microbit. Also the ESP8266. If you guys know about the ESP8266, is the most cheap microcontroller ever. It's only like 20,000 rupiah and already have Wi-Fi. But it is not as reliable as ESP32. ESP32 itself, if not in the form of the XIAO, it's only like 50,000. Still cheap. Okay, now choose ESP32. Now in the port, search for the expressive CDC. It will be different on your own computer. It will be COM40, it could be COM12, it could be COM20s. In the Mac, it will be DevTTY, AMA something. In the Mac, it will be a lot different. Did you guys find it? Is it there? Yeah, the CDC. Yes, CDC. Now choose it. Not detected. Okay, I'll be right there.
Ini baru sih, saya salah mungkin ya. Tadi pas milih ini belum ada.
Oh, belum ada.
Maksudnya apa harus tutup dulu?
Tutup dulu aja nggak apa-apa.
Oh, tutup dulu.
Nah, tutup dulu aja, buka lagi.
Apa-apa. Dari awal ya.
Oke, nah langsung bukain aja nggak apa-apa.
Oh, harus. Oke.
Ini dua.
Oh, tadi belum.
Oh, masih belum.
Apa di?
Coba ganti ganti lubang.
Apa?
Nggak ada suaranya.
Atau tutup aja ya, enggak.
Awas ini mungkin kabelnya bukan kabel data, Mbak.
Oh, boleh. Ini.
Kalau nggak coba pakai kabel aku. Ya, pakai kabel ini aja. Oh ada.
Ya,
oh ya wis. Diri satu ya. Oke. Oke. Already have this? Already configured like this? You don't have to change anything in here. If you already just click OK. Now you will be presented with the repos in here. So I need to remind you again, this Python, this repo is run on in the ESP, not in the computer, but it runs in the ESP. This IDE helps us to code the ESP inside code the MicroPython inside the ESP. Okay, now I already mentioned to you before, I want you to open this and download the GitHub, download the code, download a zip, and then extract it anywhere else. Just make sure you know the location so you can open it in Sony. It might be a bit different, but it's okay. s.id APAC24. It will lead to my GitHub with the MicroPython example. Yes. Iya di zip aja, terus di ekstrak aja. Di run. Oh ini udah. Oh ya run. Configure. Nah ini MicroPython ESP32. Iya. Ini pilih CDC. Ya. Oke. Okay, download and extract it to the location that you already know. And in the view, checklist the files option. So you can view the files on the sidebar. If you do this, you don't see the files. So quick views and files. Now, we have two sub menu. The one above is the files on your computer. The one below is the files on your MicroPython device. How to move the file from the computer to the MicroPython is not as easy as copy and paste because it's a different protocol. So I want you to open on the Sony, I want you to open the file that you just downloaded to any kind of location that you already set. Might be different. Mine happens to be in here. So it will be looks like this. Already. Mbaknya bisa, Mbak? Butuh kabel nggak? Butuh.
My battery is running out.
Hah?
My battery is running out.
Orang coba kami, Mbak. Soalnya nang di kono. Ya. Yuk. Nggak kedetek. Iya ini benar. Ya, ya bisa serial. Makanya saya bilang kalau misalkan di itu agak beda. Kayak coba oke. Wait. Komen deh. Coba klik stop. Agak beda ya. Oke, coba ganti ini, ganti shell-nya. Nah. Itu kabel C ke C ya?
Iya.
A ke C, Mas. C ke C suka kayak gitu.
Linknya dibuka lagi.
Yang tadi ya? Oke. Kabel A ke C aja. C ke C emang kayak gitu, suka ada problem kayak gitu kalau untuk shell. Bukan, dia run. Configure. Nah, itu pilih MicroPython ESP32 dulu. Iya. Ya. Aduh, sorry. Ya, USB serial. Ya bentar, USB bukan. Salahnya CDC.
Iya. Cuma di level kecil.
Oke, coba USB serial. Ya. Oke. Nah, kayak gitu sama kayak Mas yang tadi. Pakainya A ke C aja. Oh, nggak ada ya. Ya, kalau C ke C kayak gini, Mas. ini bagus. Ini bagus. Kalau C ke C kayak gitu. Oke, nanti bisa jadi nama teman yang lain aja mungkin ya. Oke. Okay, I forgot to mention that the shell, I don't know if it's the shell or the firmware itself, if using USB-C to USB-C, it will work somehow. Because when I try it also with Mac with USB-C to USB-C, code it with Arduino, it doesn't run well also. Okay, so I want you to have this same view as I do it in here. Like the above is the sample code that you are already downloaded, and the below is the MicroPython itself. Now, there are two ways to code with MicroPython. You can use the REPL directly, or you can code it in the IDE and then save it and then run it. First, we can try to code in the REPL directly. We want to toggle the LEDs, the onboard LEDs on the shell using this command. So you can open up the blink.py examples. But for now, let's try to turn on the LEDs. Yes? Pikiran. Linux ya, Mas? Ini, sudah kan dapat. Oke. Ya, ini. MicroPython SP32. Nah, ini port. Ini. Oke. Ctrl C. Ini. Stop. Ini saya. Coba ganti deh. Coba pakai ini. Oke. Is there anyone facing some problem connecting to the Sony ESP32? Okay.
You should download it Sony itself actually right now.
Yes.
So
Yeah. What OS do you?
this one,
Linux.
yeah, so there's apparently something called as Sony in EA in a Pac-Man. But when I try to do that, actually, changing to
So, yeah, because I think the Linux development has been stopped for the moment.
No, I don't know what happened to that. No, I think that this seems there's internet issues. I'm using
The Pycon.
yes, this is basically equivalent to Pac-Man basically, but it seems to not want to connect to anything.
I think the backend wheel is already turned off.
Yeah, we connect to the Wi-Fi here. So then what's going on?
Sorry, I cannot help you for the Linux OS. But if you check Linux,
Do you know if there is a
it's only apt install.
do you know if there is anything like app image or something like this?
There's another IDE called Viper, but it's a bit more complex than Tony. Because Tony,
I'm comfortable with Python itself,
uh,
but I don't know how to connect it with this device.
Wait.
That's why I'm going.
okay, maybe you can try type Viper IDE. I haven't tried it, but maybe it's suitable for you. Viper IDE MicroPython.
That's the spelling. Right. Oh, it's about right. Okay.
I think it's try to connect the USB connection. Yes. Oh, you need to use Edge or Chrome or because it use the only Chrome is not supported direct hardware modification directly. Yeah. Okay, thank you. Oke, tadi kenapa Mas? Pakai Mac ya? Iya, iya sebenarnya udah benar Mas, cuma ini udah benar, udah bisa jalan. Ini udah oke. Ini nggak ininya nih view, view-nya filenya di. Okay, let's try to turn on the LEDs using a MicroPython module. So this is basically Python 3. Print hello Python. This is basically Python 3. All Python 3 syntax, you can do it directly in the MicroPython. But there are a few differences from Python 3. But most of Python 3 syntax, you can run it in the MicroPython itself. And also, the MicroPython has some specific library or modules called machine. And from the machine, if you want to use just one object or one class, just call it the specific one class, like this pin. Now, if you look closely, the shell itself already have a few pins broken out. The shell that you are using is shell ESP32S3 sense. Sense is for the camera itself. The camera pins is already broken up in here. It's a small, tiny PCB footprint, but you can also use the broken out pin from the left and the right side of the shell. There are a few naming. This is a bit confusing actually. The factory call it D0, D1, D2, D3, D4, D5. But on the ESP32, the naming is GPIO1, GPIO2, GPIO3, 5, 6, and 40. And this is the one that's most different. This 6 is GPIO 43. So in the MicroPython, we call these GPIOs. If you want to use this pin, called 43. If you want to use this pin, called GPIO 7. So it's been broken up a bit differently. Now, there are already an onboard LEDs on the shell. It's connected to the pin 21. So we try to make an LED object, pin, and we want to set it as an output because it will turn on some data, and then press enter. Okay, salah. Sorry, I forgot the equal sign. LED equals pin, 21 pin output. So this code is basically we want to make an LED object that is connected to the pin 21, and then we want to turn it on and turn it off. There are a few ways to turn on the LEDs and turn off the LEDs. Okay, that's one way to turn on the LEDs. It's a bit backward. If you put LED on, the LED will turn off. If you put LED off, the LED will turn on. It's a bit backward. Also, another way, if you want to turn on the LEDs, you can call it like this: LED value 1 and LED value 0. And then you can check the onboard LEDs, the yellow LEDs on the shell. They'll turn on and turn off. And if you want to make it into blinking is equals to hello world in the software. The hello world in hardware is blinking. We want to import the time module first, or the sleep function. From time, import sleep as usual. Like, for example, this is basically Python for I in range. Why we have to use I? Yeah, it's common to use I. For I in range, LED on. Wait, I think I'm missing something. Okay, sorry. For E in a range, do I call it correctly in here like this? Is this correct? Is it correct? Right? LED on, sleep 1, LED off, sleep 1, and then enter, enter, enter. The LED should be blinking 5 times now, because we set it into loop for 5 times only, in the range of 5. If you want it to loop forever, just change the for into while true, and then do the same thing. Like the one from this example of the blink. Now, you already opened these examples. It's actually basically the same code that we are typing in the bottom, in the REPL. Like this. And basically you can run this code, and then you can get the LED to blink forever until you put Control C. And you can see, if you can run the code with the play buttons, and you can see the LEDs is blinking. Bisa, Mas? Bisa. Kabel tadi Coba pakai punya aku, Mas. Ya. Enggak, kalau ini mah cuma ini doang, ini cuma cas.
Oh, ini cuma cas.
Ngecas. Kalau mau ini, pay aja langsung sini.
Ini udah.
Oh, kalau itu udah selesai belinya. Soalnya, soalnya kan udah kita cuma setting range doang, 5 kali. Kalau ini kita nggak bikin terus, di play aja Mbak, ininya Mbak. Ini soalnya wire through.
Oh, belum tak tulis wire through.
Ini kiwis di sini. Soalnya kita running yang ini.
Oh, ya.
Nah, itu sekarang mau bikin terus. Okay, now the LED will be blinking constantly. Yep. Okay. Pasang udah aku. Bentar, masih kayaknya belum ke-flash kayaknya. Coba yang ini Mas. Tetap nggak bisa. Stop, bisa. Oke, buka. Toninya, coba bisa toninya. Buka lagi toninya. Oh, coba jangan pakai sudo Mas. Takutnya sudonya itu nggak ngasih akses ke USB-nya. Tuh, enable connect ini. Oh, permission denied.
Iya, pakai sudo.
Sudo. Tadi misalnya pakai sudo juga ya?
Iya.
Atau coba uninstall terus install pakai biar nggak usah pakai sudo. Emang harus pakai sudo ya emang harus pakai sudo ya? Ya coba pakai sudo lagi. Makanya errornya. Oh, berarti ada beberapa instalasi yang belum benar ini. Ada beberapa instalasi Tommy-nya. APT Git aja kan? Siap install. Soalnya ini dia older version sih. Oh, ada Python-nya nggak Mas?
Ada. Apa ini?
Kita aja coba. Sorry. I forgot your name. What's your name? Agent Kit. Maybe you can install Sony using pip. You already tried it? Pip?
Arch blocks pip.
Oh, it's a bit challenging. Coba aja pakai pip ya, Mas. Okay, everyone got their LEDs blinking? Bisa, Mbak? Bisa. Aman ya? Oke. Colokan, ada colokan nggak, Mas? Bisa colokan ya? Tarikan. Okay. Congratulations, you already have your own first LEDs blinking. Now to stop the LEDs from blinking, you need to terminate using Control C, or if you are in the Mac, Command C. Control C, and it will stop the process. Same like Python, purely Python. Okay, now if you want to move, ya bisa enggak? Ini, Control C. Apa? Linknya yang tadi. Iya, bring roti. Ada di sini, ada di source ini. Ada di sini. Oh, ini yang tadinya ini yang hijau. Okay, now the bring.py file itself, it doesn't exist on the MicroPython. If you want to move the bring.py file into MicroPython, it is not as simple as Control C and Control V. It's not copy and paste because it's a different interface. So if you want to move the bring.py, you right-click on the file and then upload to this. Just click it, and then the bring.py will be exist on the MicroPython. So using this, before I am using MP tools. MP tools is all command based. Using Tony is very much helpful right now. Okay. Actually, oh, we have half hour. Okay, now we want for you guys holding this module. This is called the XIAO expansion module, and it already has a screen. Now, now we want to try to put something into the screen. So, before you begin, I want you to upload the lib. Is it already there on the MicroPython? This lib folder? Udah ya? Betul saya copy. Saya mau copy. Okay, the lib folder is actually where you put your custom library. So like the MicroPython from itself already have its own built-in libraries, like the machine library, sleep library, the basics Python libraries. It's already there. But for the screen, it has its own library. It's not on MicroPython itself. It's called the screen type is called SSD 1306, or you can call it OLED screen. It's basically OLED. And I already put the library in the lib folder, and this is the library SSD 1306.py. It's basically calling the function to work on this screen or OLED. And okay, and the screen itself is actually run on I2C. I2C is interface protocols that uses only 2 pins, serial data and serial clocks, and it's based on the address. So if I unplug the shell and then run this I2C scanner again, oops, I unplugged the wrong things. Okay. Now if I run this, it doesn't show anything because there are no I2C device connected because it's not connected, no device. Now if I connect this, it has 2 I2C devices on this module. One is the RTC modules, and the other one is the OLED itself. Now, if I run this, the I2C scanner has 2 addresses. One of these addresses is the address for the screen. So this is not mandatory. This is only to check if there is something, some I2C device is connected to your shell or to your microcontroller. For this one, I will explain later. For you guys who hold this one, I will explain about after this. Now we want to put something into the screen. I already have this OLED test. It's actually you just run it and then it will show something there. But I will explain the code. I will break down the code. Just play it, and it will show the text precisely like the one in here. So in here we call the time libraries machine libraries, and the machine libraries also we not only call the pin libraries, but also the pin function or the pin class. We also call the I2C class as well, because you want to use I2C device. You want to make a connection with I2C, and we break down the I2C connection. It's actually connected to the pin 6 and pin 5. Pin 6 is SCL or serial clock. Pin 5 is SDA or serial data. This is the standard for I2C. So if you are looking at a sensor, if you are looking at a sensor and then you see an SCL and SDA pin is mostly I2C. So if you see the microcontroller device, a sensor, and you see some pins labeled either SCL and SDA, it has to be an I2C device. Now we specified the pixel, the width, and the height of the pixel. The screen itself has 128 width, lebar, and 64 pixel height. This is in pixel, not in centimeters or in inch or in millimeters. No, this is in pixels. 128 by 64 pixel. Okay, now we made an OLED object, specified all the configuration that we already set up above before. And then OLED field zero. OLED field zero is basically wipe the whole screen. If there is something on the screen right now, wipe the whole screen. Like right now, it's already have the some text, right? Now, if you type OLED field zero in here, OLED field zero, and then OLED dot show, your screen will be blank. OLED field zero, let us show. Okay. So now OLED field zero is wipe the whole screen, and then OLED.text is what kind of text we want to put. As long as the text doesn't override the width pixel. Like for this instance, you can write Pycon APAC 2004, and then here you specify the position of the text. 10 minutes. 0 and 15. 0 is the X1. This is the Y position. Sorry, the first one is X position. The second one is Y position. So remember, like X and Y position, right? And then this is the second one, still in the same line, but different row. So this one is the different row and different line. Okay. Now open up the OLED weather. This one has bug, but somehow when I test this in my house before last night, it's working. The Wi-Fi is working. This is actually a code where we can grab some JSON data from an API. Like for this example, I'm grabbing the data from the weather API. Actually, the endpoint is, but somehow the Wi-Fi isn't working. I don't know why. Wait. Okay, so this one is the weather for Yogyakarta from Open Weather API. Sorry, from openweathermap.org. You can also make your own API tokens if you log into if you register to the Open Weather Map. As you can see, this is. Let me try to zoom this. Okay. Longitude, latitude, weather. Today in Yogyakarta is clouds. Yes. The temperature is 29. Yeah, I think it's 29. It's not that cold. Not 22. It's not that hot. Also over 30. So yeah, this is basically Yogyakarta. The weather in Yogyakarta. So now I want to put the weather of Yogyakarta into the screen. Grab the JSON file and then extract the data that you want to show. But in here, if you check my weather examples, I already remove. Oh, I still have my API, so you can use it. I thought I already. Okay, you can. So it already have my API, so you can use it. I don't know how many calls. Habisin aja ya code-nya. Oke, OLED-weather.py. So I open OLED-weather.py and then change the Wi-Fi configuration with your own Wi-Fi, or you can change it to connect it into the UNU Yogyakarta. Case sensitive. Case sensitive. Remember. And this is the password site. Just fill it with nothing. Don't fill it with space. Fill it with nothing. No and zero is a different thing. Okay. Fill it with nothing. Okay. Set the Wi-Fi into like this and then run it. I think. Okay. Who have this error? You guys say, okay, one. Who has succeeded to grab the data? Success. Alhamdulillah. Success. Because I have this error. For all the device that I test, I have this error. Iya, jadi bisa. Diulang lagi aja. Kalau misalkan ada error, coba diulang lagi. Ulang 3 kali. Kalau nggak bisa, ya udah. Pasrah. Try to repeat it 3 times. Bisa. Beda device. Bisa ya? Kalau ini, kalau yang itu bisa. Oke. Hah? Iya, harusnya sih berhasil. Harusnya, maksudnya aku ngasih lihat itu karena beberapa device yang aku pegang itu ada error gini, tapi beberapa dari teman-teman berhasil. Coba running lagi.
Start lagi.
Oke. Bentar nggak?
Sorry.
Ini udah.
Oh, oke.
Okay. Now on your screen, if you are successful, you will have the data of Yogyakarta temperature, Yogyakarta weather. Okay. Yogyakarta weather for today. If we break down, we are in the code. I only extract a few things: the main temperature, the weather, the city name. Only the temperature and the condition and also the city, and then I put it in the screen. Convert the temperature, convert the temperature into string because the data is in integer. You need to convert it into string so it can be printed into the OLED screen. And then the city doesn't need to be converted because it's already in string. And also the condition also doesn't need to be converted because it's already in string. Only the temperature and the humidity and the integer type of data that you need to convert, and then you can show it into the OLED screen. I need 2 more hours. Aku butuh 2 jam lagi sebenarnya, tapi it's okay, nggak apa-apa. Because I haven't get into this part because this thing is a camera, ya benar. This thing is a TinyML device. It can run its own TinyML model, and it has a better frame rate. Wait. Mas, bisa tolong dokumentasi nggak? Ini buat dokumentasi aja. Dokumentasi dong, boleh? Foto aja. Di sini aja, ini ada begininya. Oke, ini adalah ini ya. Mandatory aja ini, mandatory. Oke, ini sebenarnya salah satu company juga yang bawa saya ke sini di Tanking Hub dari Jakarta. Beberapa proyeknya saya mau share aja sedikit ya. Ini proyek yang lagi dikerjakan adalah anti-collision. Anti-collision untuk beberapa kendaraan di sebuah area yang sangat luas. Kita butuh AI, kita butuh LoRa, kita butuh solar panel. Yeah, we need LoRa, solar panels, and all this stuff. So what we want to do is to make the driver aware when there is another vehicle near them. This is the test. Test is on the suburban, on the perumahan or kampung. but the implementation will be in the huge field or a huge mine, a huge tambang. So this is the POC. It already has AIs and compute cam all installed into the car. But it's not auto driving. No. Kita belum sampai sono. Yeah. Okay. The other one that I want to share with you is this module. Don't have the time, sadly. Global Vision AI modules. Sorry. Mbak minta 2 menit aja Mbak ya. 2 menit aja. Okay. Let me demo this. So this is the SenseCraft modules. Okay, Vision Workspace, Vision, Connect. Oke. Ada respon timeout. Tidak. Disconnect. Connect lagi. Okay, so this is running a person detection. As you can see, this is have a great FPS to detect person. Can I have my USB cable back? Actually, I want to show you how to interface this device using MicroPython. So you can grab the data, the interesting data using MicroPython. That's for the final part of this workshop, actually. Okay, again. Sorry, it's so noisy. So this detection runs. Udah. Oh, time's over. Okay, time's over. So this module runs the data model itself on the device directly and has a better FPS. Okay, thank you. Okay, thank you guys. Time is over but if you have another question or want to discuss this stuff with me, I am still here until inshallah Sunday. Inshallah Sunday. Until Sunday. Tomorrow I'll be here also at the opening. And also maybe we'll do a lightning talk where I'm building my custom mechanical keyboard using CircuitPython or MicroPython. So you can run your Python on your keyboard. You know my mechanical keyboard, right? Yeah, custom mechanical keyboard. Yeah, blue switch, right switch, right? You can build your own custom mechanical keyboard using MicroPython, and you can configure your own keys using MicroPython or CircuitPython. Maybe on the lightning talk. So guys, thank you for your time. Thank you for your attention. I'll see you again, maybe sometimes later. Oh yeah, alatnya balikin. Oh, I forgot. I want to give you this sticker. So, lupa. Stickers for everyone. Ya, tukar. Tukar. Kalau mau running on boot, filenya diganti main.py. Main.py itu jadi file sistemnya itu si MicroPython itu dia akan ngecek dulu does it have main.py? If it has main.py, it will run directly. So you need to put the Blink code into the main.py files, or rename the Blink code as main.py. Vice versa. Welcome.